Thank you for joining me that I can introduce Autoclaved Aerated Concrete to you. Autoclaved Aerated Concrete is also known in a shortcut as AAC. My name is Michael Hoffman. I was raised and born in Germany, and I earned my construction degree in Germany as well. It was in 1986. So 10 years later I moved to America to build and to promote for Autoclaved Aerated Concrete. The following presentation will take approximately 45 minutes, so sit back, relax, and enjoy the presentation.
MHE-International is a company which specialized in design engineering, sales marketing, material supply, and construction of autoclaved aerated concrete. AAC has been specified and used in residential, commercial, industrial, hotel and motel, education such as schools and universities, healthcare like hospitals, shaft walls, and for sound barrier walls. Let's talk about the AAC history. Actually, it was first found in Germany in 1880, without the present steam curing process. A Swedish architect in 1918 developed the material as it is today, which includes the steam curing process. The first production in America began in 1993. Currently more than 300 AAC manufacturing facilities worldwide, which results in more than 30 million cubic yards produced annually. This is enough AAC for approximately 330 homes every day. Since 1986, MHE has provided for and built successful projects around the globe, and we work closely with each country and every continent and their AAC facilities. It consists basically of water, which later becomes the air once the moisture is removed, aluminum powder or paste, quicklime, gypsum, Portland cement, and quartz sand. The cement and quicklime reacts with water in an exothermic reaction to calcium hydroxide and semi-crystallized calcium silicate hydrate. Basically, this reaction stiffens the material. The aluminum reacts with water, and the hydroxide ions which have been made available during the cement and quicklime reaction. So hydrogen gas H2 is generated, which produces a tiny little pores. The percentage used of each raw material is not just a guess. AHC is produced in several different compressive strengths. As more H2O is introduced, we produce a lighter material, and we increase the R value. However, decrease structural values and decrease the sound value. But if we use more quartz sand, for example increase the volume to 70%, we increase the structural value and increase the sound value. However, decrease the steady-state R value. The final hydration product is also called turbomerite, as seen here under a microscope. You can see numerous air pockets. However, not all are connected, which gives AAC the unique properties. Most AAC facilities are well advanced and have just a few workers. Everything is computerized and robots pouring, moving, and autoclaving the product. The technology today makes it possible that each mixture ratio is very accurate, controlled by computers, and the material has just 1/32 of an inch size differential. When producing AAC with quartz sand, the ball mill will assure the grinding of the proper consistency of the sand, which is wet grinded. There are few manufacturers which are using fly ash instead of sand. Those facilities do not require the ball mill. Basically, it begins with the sand, which is the dominant raw material. The sand will be mixed with water in large slurry tanks. When we produce reinforced units, which are wall panels or floor panels or roof panels, we receive the reinforcement in form of spools. Those spools will be straightened and cut to length. Then the fully automated reinforcement cage welding machine connects our longitudinal and latitudinal bars together in the spacing as our engineers have it designed. These are completed welded reinforcement cages, designed to specification for either floor, roof, or wall panels. Before we introduce the reinforcement cages into our mixed raw material mold, we protect the cages with a corrosion treatment. Here we pour the pre-mixed raw material in our forms. In this curing room, the aluminum paste finds its reaction. As you can see on the top right picture, there is a 3 to 4 inch space. Then after 8 to 10 hours, the reaction is completed and the AAC in the green stage did rise to the top of the form. Also the cement reaction occurred so that the material is stiffen enough that we can unmold the AAC. Now the material is ready to be cut to size. As you can see here, those wires, very fine wires like piano wires, will cut the material in 2-inch increments. Will cut the material very accurate. All remaining materials which is cut off will be recycled and is being reused. Recycling and reuse of material is very important to us. So the material which was just cut off will be reused, and also recycling silos will store and use recycled raw materials. So in order to cut those profiles into our wall, roof or floor panels, we use those profile knives right after the wire cutting process. This is a vertical load-bearing panel without a profile. This is a vertical load-bearing panel with a half-round profile to add a vertical reinforcement in the center of the wall thickness, in a spacing required by the engineer, which is in accordance with the local requirement. This is a panel with 2 half-round profiles, used when the vertical reinforcement spacing is every 24 inch on center. This is a horizontal panel used mostly for cladding on structural steel or concrete. The last panel is one of our floor panel profiles, which is also available in tongue and groove. Here is the most important part of the process, the autoclave. Also here we are very energy efficient. Before discharging an autoclave, which holds 12 bar of pressure and a temperature of 350 Fahrenheit for about 10 hours, we reuse the remaining steam by loading a new autoclave with the material, closing the autoclave, and then using the steam from an autoclave which is ready for discharging. So we push the remaining energy from autoclave to autoclave. So after about 10 hours the material is ready for discharge. The material has approximately 30% of water content. During transportation, delivery and installation, it will lose approximately 15%. The normal and healthy water content is between 4 to 8%. We also produce U-blocks, or as known in the masonry industry as knockout blocks. Those blocks will be used for tie beam, or known as bond beams, or for window and door headers. This could be your panels, waiting for our freight company to pick them up and deliver to your job site. See how easy it is to build a house with pre-engineered panels. Vertical load-bearing panels, header panels or lintels for door and window openings, floor panels for multi-story buildings, all produced to size with a tolerance of 1/16 of an inch, which is 1.8 millimeter, and marked for easier and faster installation. And also here, reinforced panels for the second floor. We can install a panel every 3 to 5 minutes. Roof panels to create a fire-rated envelope and for maximum thermal performance in achieving a true 100% green and sustainable envelope. Easy completion with traditional roofing material, adding the gutter system, installing doors and windows, and even adding an autoclaved aerated concrete chimney. Please see our website or find us at YouTube to see actual buildings built with reinforcement panels within just a couple of days. What are the advantages of using autoclaved aerated concretes on your projects? AAC has the highest fire rating in the industry for non-load-bearing wall applications in the United Laboratory certified AAC for 1 hour per inch, which is outstanding in the construction industry. As seen on this picture, an AAC fire-rated separation wall was used between 2 buildings. This warehouse was a metal building with structural steel components. The warehouse had chemical items stored, which by a fire developed a temperature of up to 2000 degrees Fahrenheit. This is a temperature where steel loses its structural value and starts to deform. AAC can withstand an outstanding 2190 degrees, and this more than 100 hours. Let me show you personally how this works.
So I have a regular propane torch here, which can develop approximately 1995 degrees. So I will use it as you can see here, and hold it right onto the AAC, which is only 2 inches thick. So right now I'm coming close to 1000 degree, 1500 degree. And now you can see the red spot already. So now I'm close to 1995 degrees. It's where steel basically starts to deforming slowly. I don't feel anything else on the other side. I can do it all day long. But I need my propane tank for another presentation, so I will stop here. It's basically the rule of thumb. It's 1 inch, 1 hour fire rating. What I will show next is that AAC is very airtight. So what you need in order to keep a fire burning, it's first of all the fuel, which could be anything in a house, furniture, carpet, and what you also need, it's air. So what I show here in this little box, it is 2.5 square inch hole, what we drilled in here. I will light a candle. I will put the candle into the 2.5 inch hole and add a lid on top. So after approximately 14 seconds, the candle will extinguish, which shows you basically if you have a building where it starts burning inside, and you have an AAC walls, floor and ceiling, the air will not come into the building in order to keep the fire burning. Sure, you need fire-rated doors and fire-rated windows. So that will be approximately now 14 seconds, and as you can see, the candle is off.
I believe this picture speaks for themselves. The only house which survives the large fire in 1993 in Laguna Beach, California. Would you like to build fire safe in order to protect your assets and your life and the life of your family? AAC is lightweight. It is a fifth of the weight of concrete, which is easier to install and does not require heavy equipment or large labor force, which results in lowering handling cost. AAC even floats. Millions of independent air pockets making this possible. AAC is absolute energy efficient. AAC is the only 100% green single wall construction unit in the US with excellent thermal values. So what we all like is keeping the cold air outside in the winter and keeping the hot air outside in the summer, and maintaining all year round a constant interior temperature. So how can we do it? First, with our excellent thermal resistance. AAC has a thermal resistance which is 10 times better than concrete. Secondly, with our high thermal mass values, also known as heat capacity. So the mass wall benefits with a time lag which is simple, that the exterior temperature fluctuates during the day and throughout the night. But we like the interior temperature constant, so that we don't have to reheat or recool every 1 to 2 hours during this time period. So when building with an AAC wall, only 8 inch thick, the interior room temperature remains constant for 8 hours. See this table. Within the 24-hour time difference and 130 degree temperature increase, the interior temperature of an 8 inch wall remained almost constant by plus minus 8 degrees. AAC is only slightly air permeable. Without considering the joints, windows and doors, the air escapes at a rate of 0.03 per hour per cubic yard, which 1 psi pressure difference, which is 20 times better than the passive house regulation requires. AAC has no thermal bridges, like other traditional building systems, so no air can escape. Our specific heat values of an 8 inch AC block is 2.5 times better than a 3.5 inch bedded insulation board. So there is no need for any additional insulating materials. AAC actually absorbs sound. Walls, floors and roofs constructed with AAC reduces the transmission of sound, which results in virtually soundproofing the interior rooms. And why? Because AAC is 60 to 70% air, with mostly enclosed air pockets. AAC exhibits higher sound absorption than traditional concrete products. up to 9 decibel better than material of the same weight. The sound transmission class, known as STC, is a single number rating of the ability to resist the airborne sound transfer at frequencies between 125 to 4000 Hz. Even with a STC rating, any penetration, air gap, or flanking pass can seriously degrade the isolation quality of a wall. AAC has no air gaps and no flanking passes. AAC outperforms in all frequencies any other building materials of its weights per area ratio. So as an example here, you have an 8-inch exterior wall and a car alarm starts outside, which creates around 110 decibel. Our 8-inch wall reduces the sound by 51 decibel, which is almost half. Calculation data based on the weight per area was calculated to resist only up to 46 decibel. Here we outperformed it clearly. Let's see the last test. An intermediate floor panel with padding and carpet. Let's assume a family in the second floor has a party with friends and are dancing and playing music. They can create noise between 90 to 110 decibel. So an 8-inch AAC floor panel can resist the airborne sound transfer by 70 dB, so that only 30 dB is remaining, which is the noise level of a library. Normal noise levels for playing children is around 50 decibel, and street noise is 80 decibel. So just have to resist an airborne sound transfer down to remaining 20 dB in order to have a good night's sleep. Easy achievable with an 8-inch wall. Let me show you a little test.
Okay, so let's assume you have a house built with autoclaved aerated concrete walls, floors, ceilings, and even the roof. So you have noisy neighbors, outside noise, car noises, or even your own kids will do a party in the second floor. So let me show you how it is if a noise with 25 decibel occurs next to you and you want to watch your own TV show. I will put this media player into the box as you still can hear it. Now we add a 2-inch lid on top. You hear how quiet it is? Now you can enjoy your own TV show and relax.
AAC is weather resistant. AAC withstands the wind loads of Category 5 tropical storms. Several AAC homes faced the triple attack from the 2004 Florida hurricanes and were still livable. In Lake Wales, Florida, a contractor had added a 1,200 square foot AAC addition, which suffered no damage during the hurricane. The stick frame portion of the home was utterly destroyed. I myself lived for 10 years in Florida and experienced several hurricanes firsthand. AAC passed the stringent Dade County P201 large missile impact test. Let's check out some clips from this day of the test. You can see this 2x4. Wow, this was fast. Let's see it again. This 2x4 was projected with 34.7 miles per hour. And this test was done in 1997 for Dade County, Florida, the most stringent hurricane county in the US. This projectile did only indented the AC by a quarter of an inch. AAC even withstands earthquakes. In the 2007 MSJC, the Masonry Standard Joint Committee, rated AAC for all seismic design categories. In 1995, an earthquake hit Kobe, Japan. Over 5,000 AAC homes withstood the massive quake with no damage. 300 homes had minor damage. In seismic areas, the low unit weight with a high strength ratio is an effective part to make AAC such a great structure material for those areas. AAC is mold and mildew resistant. I think everyone has seen this kind of picture. A concrete building with one wall of drywall, full of mold and mildew. This will never happen with AAC, because AAC is a mineral-based, non-organic building material. For example, the gypsum in the drywall is non-organic too. However, the paper on the drywall is organic and creates a mold and mildew. So, moisture in the room, which normally occurs, cannot escape in concrete buildings. and as soon as the temperatures cool down to the dew point, either naturally or with an HVAC unit, the moisture molecules become now water pellets and start feeding organic items, like the paper on the drywall. AAC is a non-organic mineral-based material. AAC does not promote the growth of mold and mildew. AAC is a vapor-permeable system, so any moisture in the room can travel safely throughout the wall and escape, while the water molecules, which are far larger, cannot travel throughout the material. By the way, the correct moisture content in the room should be between 40 and 60%, which AAC can easily assure. This improves the indoor air quality. Even driving rains and water will not penetrate. As you can see, AAC even floats. So if we ship AAC to an island, don't worry, your material will arrive. AAC is pest resistant. AAC is impervious to attack by insects, rodents, and termites. Termites and ants do not eat or nest in AAC. Solid wall construction and finishes bond to the wall, leaving no cavities for insects, termites, or rodents to dwell in. So the result is reduces the need for pest control, offers maximum protection against damage from pests. This is especially important in warm and moist areas. Termites can even penetrate concrete when they know that wood is behind. However, AAC, with its large contents of quartzite, cannot be penetrated by termites. Their glances cannot digest the quartzite particles. AAC is environmentally responsible. AAC is a 100% green building material. There are no pollutants and no toxic byproducts in the manufacturing or construction process. AAC is also sustainable. It is a long-lasting material which requires minimal maintenance. It is manufactured with abundant and or recycled raw materials, and it produces no waste products. AAC is environmentally responsible. AAC qualifies for numerous lead points, which I can explain in a couple of seconds. AAC is also manufactured with abundant and or with recycled raw material. AAC is manufactured by using the least amount of energy, as you can see on the left graph. AAC is using only 280 kilowatt hours to produce 1 cubic meter of AAC, while you need 900 kilowatt hours to produce the same volume of brick. Now look at the right graph. Because AAC consists of 80% air, therefore the finished product has up to 5 times of the volume of the raw material. Basically, you need only 1 cubic meter of raw material to produce 5 cubic meter of AAC, while for concrete, you need 1 cubic meter of raw material to produce 1 cubic meter of concrete. Let me show you how AAC can contribute to your LEED credits. First criteria would be energy in atmosphere. When choosing the right window and door package and using an AAC shell, which includes floor and roof panels, you can achieve up to 13 points at this criteria. Next criteria is material and resources. The great value of AAC, which is possibility of being recycled, having the project close to an AAC plant and maintaining parts of an existing structure can contribute up to 8 points at this criteria. So the next criteria would be indoor environmental quality. Our unique airtight properties of AAC and our high thermal properties can help you to achieve 4 points for this criteria. The next and the last one is innovation and design process. By being absolute termite resistant, another point can be received. So overall, AAC can contribute to 1 prerequisite and 23 LEED credits towards green building certification. If platinum level is achieved, all fees associated with LEED credits are refunded by the USGBC and approximately $20,000 credit back to the building owner from the USGBC. Let me summarize all of our AAC benefits. Fire resistant. It withstands up to 12 hours at 2190 degrees Fahrenheit. Lightweight. AAC is 5 times lighter than concrete. Energy efficient. AAC has the highest thermal rating in the industry for its mass, up to R30. Absorb sound. virtually soundproof interior rooms and to the outside. Weather resistant. AAC withstands the wind load of Category 5 tropical storms. Mold and moisture resistant. Driving rains and water will not penetrate, and AAC does not promote mold and mildew. Pest resistant. Termites and other insects cannot penetrate AAC. Environmentally responsible. AAC is a true 100% green building material. Cost saving. Higher quality and lower overall cost. So how does our structural system works? We can use standard blocks in sizes of 24-inch long and 8-inch high and thicknesses in 2-inch increments, so 2-inch, 4-inch, 6-inch, 8-inch, 10-inch and 12-inch thick. Or we can use jumbo blocks, which are 2 feet long and 2 feet high and have the same available thicknesses. Or we use load-bearing panels with a maximum height of 20 feet and a standard maximum width of 2 feet, which have the same available thicknesses like our blocks. So let's see here how load-bearing panels were installed already in 1923. MHE installed 63 years later their first reinforced panels in Germany. The key for using panels is a reinforcement cage. Bars between 5 to 8 mm running in both directions to reinforce the elements. We call those units reinforced elements. AAC panels as cladding for concrete, steel or wood structures. AAC panels with its maximum length of 20 feet can be used in a horizontal application for cladding of post beam structures. If the base span exceeds 20 feet, we use the panels in a vertical direction so that we can span from elevation to elevation beam. AAC panels can also be used for elevated foundation slabs and for intermediate floor slabs on multi-story buildings for commercial or residential projects. AC panels can be used for AC roofs for all shapes. The advantage is having a full fire-rated envelope and having a roof which performs thermal and cold areas as well as in hot areas. It is very easy to route for utilities or for architectural details, any lines or any shapes. It is easier to handle than wood. Routing made easy. AAC exterior finishes is also available from MHE. In all colors, special produced for AAC walls and ceilings with a wide variation in textures. Interior finishes is also available from MHE. Also here available in all colors and in all styles, from smooth finish to orange peel. For special projects, we can already produce panels with a design routed into it, which will reduce the on-site labor. Those panels find its use especially for commercial or sound barrier wall projects. Let me show you some of MHE projects. Let's look at some hotels and motels built with AAC. AAC is one of the best shaft walls materials available. It's great fire rating, mold and mildew resistant, and its capability to release moisture made it one of the most desirable materials to build shaft walls and demising walls in high-rises. This hotel was built in 45 days for Steinmetz Construction in Lady Lakes, Florida. MHE, with its own general contracting division, built this hotel in Ocala, Florida in 2004 as a turnkey project. MHE was also the construction manager and finished this project in less than a year. This hotel is direct on the interstate and it's still one of the most quietest hotels. So let me show you some commercial projects. First AAC building in the state of Hawaii, a Burger King. The owner Kasi Foods hired MHE to complete this project. MHE was training the local workforce, managed the AAC installation and re-engineered several components. Kasi Food is the second largest franchisee in 2008, was so satisfied that they authorized MHE to build another restaurant just across the street, a KFC. One of the largest general contractors in the state of Hawaii saw the performance of MHE at the Burger King and KFC, and he shortly decided to use this revolutionary building material. He saved more than 20% versus a traditional building material on construction cost. So let's go to Texas. MHE installed one of the largest rental stores in Woodland. Just 4 men and a crane operator installed this store within just weeks. The general contractor was amazed at the installation speed by MHE. The architect liked the appearance of the material and the ease of workability and is promoting AAC since then. MHE installed exterior panels for an IMAX theater in Tallahassee, Florida for Peter Brown Construction. AAC panels were required to fulfill the high sound value. A very short time schedule on a limited place was given. MHE, as the most trained and experienced AAC specialist, went up to the challenge and performed in time to excellent quality. We also built numerous churches. Here just one example, a church in Florida. Schools and dormitories. A test was performed in Washington, D.C., where the test institute found out that children are studying better in a green environment with an excellent air climate. Sure, AAC was actually the best choice. So after this study was completed, we did build quite some schools. The Southeastern College of Lakeland, Florida designed 3 phases of his dormitory. Here are the second phase, where 17,000 square foot of AC block and panels were installed. This is one of the most quiet dormitory built in the US. Students enjoy the absolute sound protected rooms, and the energy cost is less than half than in traditional buildings. The fire rating gave the college a peace of mind. To know that this building will remain free of mold and mildew was very important to the parents of the students. MHE installed up to 2,000 square foot of wall area every day, so that the building could be completed within less than 2 weeks. More universities and dormitories heard about this success and built their structures with AAC. So let's see some residential projects built by MHE. In 1999, we built multifamily homes. A 6-plex, 4-plex, and 8-plex was completed in less than a year. AAC block for all vertical application with a traditional wood-framed roof was used. American Heritage was the owner and was well satisfied with MHE performance. MHE built this house in the Caribbean islands, in Anguilla, which is the British West Indies. The great protection of the heat intrigued the owner, who is by the way originally from France, to build with AAC. MHE did the complete engineering service, provided the material, and trained local workforce to use the material. The owner wanted to try to set some AAC blocks and was so amazed how easy it is with the right guidance. He will definitely build his next house with us again. As you can see, the owner was a happy customer. Even couple islands away they heard about AAC, and short after, MHE started to work on their first AAC prototype on the island of Tortola. Let's look at the 3-story residence in Hawaii, a 5,000 square foot house with a pool. Due to the extensive use of windows on the west side and having AAC floor panels on this project, and thus also in a seismic zone D, we used a moment frame structure. MHE did the complete design and engineering, provided the material, and installed all structural items and the AAC reinforced elements, and also delivered the excellent Austrian window. Let's look at this residence. The owner stated that he is saving $500 on energy bill every month in comparison to his previous house, which was a standard stud frame house with the same size. By living in a full fire-rated shell and termite-proof house lets Mr. Stephen Withers feel absolute safe all year around. In 2003, MHE was a project manager and supplied its major staff for this largest AAC sound barrier wall project in the US. Within a year, 23 miles along SR51 were installed with a production rate of 8,000 square foot a day in a 24-hour shift system. For US production on request, our material is in accordance to ASTM C1452 and ASTM C1386. We also design in accordance to ACI 523 and ACI 530. We can produce AC material with a compressive strength of 1090 pounds per square inch, known as PSI. So our standard block with dimensions of 8 inch by 24 inch gives us an area of 192 square inch. Multiplied by the 1090 PSI results in an available calculated gravity load of 209,664 pounds, which is 95 ton. So this 95 ton train can easily stand on an 8 by 8 by 24 block. Let's see if I can break with a hammer the AAC block.
Even if AAC is 5 times lighter than concrete, it is strong. Let me show you that this hammer cannot break the material. It just indents it.
Let me show you the basic AC tools you will need to install your AAC building. The AAC band-saw, AAC panel clamps for vertical panels and horizontal panels, an AAC floor panel clamp, and the old-fashioned German handsaw. MHE-International, with its staff of licensed architects and designers, are able to design any project which you may desire in autoclaved aerated concrete. Also, when your architect or designer completed its design already, we will help and assist to modify it to an AAC-friendly design without changing the architectural features to maintain its original character and intention. MHE-International is providing a full support service for architects and engineers with full CAD service for all AAC applications, as load-bearing or non-load-bearing walls, interior walls, or floor and roof slabs. MHE-International has also a complete staff of licensed engineers to engineer your project accordingly to the highest AAC standards. MHE-International is also providing full fabrication and installation drawing service for all reinforced elements if chosen for exterior walls, interior walls, and for floor and roof slabs. Let's hear what others have to say about autoclaved aerated concrete.
We're pretty enthusiastic about it. Beers is pretty enthusiastic about it.
We had a very poor soil condition. The weight of this project being lighter than normal masonry allowed us to put in a foundation system much more economical than we would have needed with conventional masonry construction.
The flexibility, the ability to design block walls, single wide masonry, without having to deal with putting anything else in front or in back of it. Definite advantage.
The ones that count for us is from the teachers and principals in the schools. And what we're hearing is we want more.
The product has a tremendous track record overseas in Europe.
The fire rating and the acoustical properties is far in excess of what's currently available.
My boss is loving this. He is absolutely adamant about using this product wherever he can.
The buildings and all in Europe typically have been there a lot longer than most of the buildings in the United States, so we felt that the product had a lot of research behind it.
The nice thing about using single wide masonry is that you don't have to add anything. The insulation's inherent.
All projects around the globe found full satisfaction by all our customers. Since 1989, MHE has constructed buildings from single-story to multi-story. Thank you letters and reference letters were issued to MHE, and each customer recommended us further. Autoclaved aerated concrete, the perfect solution for your projects. From basement to the roof, all AAC. There is no need anymore for drywall, flooring strips, or any other material. One single solid wall unit, finished on both sides.
Thank you everyone for allowing me that I could introduce autoclaved aerated concrete to you. Please feel free to contact us at 1-888 847-1077 or visit us online at MHE-International.com.